First of all, dogs, they just got haircuts. So, Murph and Ava. All right. So we are dealing with transformations of functions. Fairly heavy section. It's going to take a couple of videos. So I'll try and be as brief as I possibly can. So the first thing that we're going to talk about is a vertical shift. And the trick for a vertical shift is you're adding a constant to the function. So if your original function is 2x plus 4, and we're going to take and make a new function, call it f of x, and we're taking the old function and adding a 2 to it, and in your book it'll say plus k. You're really doing 2x plus 4 plus 2, which is 2x plus 6. And if you're looking at what the original function was, here's the y-intercept of 4, and the ordered pair here is 1, 6. Now, you slide this up 2 spots, and you're sliding this up 2 spots because it's a vertical shift up of plus 2, okay? And so the new function 2x plus 6, y-intercept of 6, up 2 over 1 following the slope, okay? And so the comment I make when you're dealing with a vertical shift, it moves the same direction as the sign of the value. Okay, so a horizontal shift. Well, what you're going to do here is you're going to add a constant to the argument. And so if we take our previous function that we had, which was f of x being equal to this g of x, this 2x plus 4, what we do is we put the minus 3 in the argument. So we read it as x minus 3, f of x minus 3. And then you're going to take the g of x and make it g of x minus 3. And then we put the x minus 3 in place of the x. And so this becomes 2 times the quantity x minus 3 plus 4. Distribute the 2, so we have 2x minus 6 plus 4, or 2x minus 2. And what you'll notice when we graph this, again, here's the original line. Y-intercept 4, go up 2 over 1. We have a new y-intercept of negative 2, and you go up 2 over 1. And it's not as obvious in the linear functions. But what's happened is this point is now shifted over 3 points that way. And if I had been very careful and could have drawn it well, this would have been moved over 3 spots here, and so forth, okay? Another example on this one. So suppose f of x is equal to x squared. And we're going to try and move it 3 units it'll be to the right. It's the opposite of what's the sign is. So f of x minus 3 is x minus 3 squared. And yeah, you can multiply that out, and you get x squared. You get minus 6x plus 9. Sometimes this is more helpful. So if I let my x be 0, I'm at negative 3 squared, which is a positive 9. So in my new function, I'm up here. And if I let my x be 3, I plug that in there, 3 minus 3 is 0. I'm crossing or touching the x-axis. So the original function, the x squared, has now been shifted 3 units to the right. Okay, and the origin sometimes is more, or is a better visual cue of what's going on. So that's 3 units right. All right. Now we're going to deal with vertical stretch and compression. And we're going to deal with them the same way. So if you're multiplying by a number that's bigger than 1, it's a vertical stretch. And if you're multiplying by a number that's smaller than 1 but bigger than 0, it's a vertical compression. If you throw in a negative there, it actually turns the graph over, and we'll talk about that in just a second. Okay, so if we start off with x squared and we do that versus 4x squared, well, 0, 0 doesn't get adjusted, but we used to have on the x squared the ordered pair 1, 1. Well, when I plug a 1 into the x squared times 4, I'm now up at 1, 4. So this is pulling the graph up and making it narrower. The the climb is 4 times quicker. It's not really slope, but it's kind of like the idea. Okay? All right. Reflection about the y-axis. And also, if a function naturally does this, like x squared, it's called an even function. So if f of x is x squared, f of negative x is negative x squared, which is the same thing as x squared. And so if you take and see f of x and it's equal to f of negative x, you get what's referred to as an even function. We'll deal with odd in a little bit. But it's taking the points and it's reflecting it around the y-axis. So if x is equal to negative 2, you'll get positive 4. And x is equal to positive 2, you'll get positive 4. So when you look at the graph, 1, 2, 1, 2, 3, 4, there, negative 2, 1, 2, 3, 4. Not perfect scaling, but you get the idea. Okay? Now we'll turn the page. Another example. Suppose f of x is equal to 2x plus 4. And we'll take f of negative x. Well, that's negative 2x plus 4. These are not even. They would have to be exactly the same, sign for sign, variable for variable, and so forth, in order for it to be even. And this is the test to see if they're even. But they can reflect around the y-axis. You can reflect something around the y-axis. So in this instance, this is the original function. There's the 4, up 2 over 1. Now, that ordered pair right here is the ordered pair 1, 6. Now, if I take negative 1, I need to get 6. So here's my new line, negative 2x plus 4. This is the reflection around the y-axis because it's changed the sign of the x, and the y values still match. And so if I take negative 1 and I put it here, negative 2 times negative 1 is 2. 2 plus 4 is 6. And there's my 6. Okay? And hopefully that makes sense there. All right. But I will make that comment again. This is not even because f of x does not equal f of negative x. All right. Now, if we want to reflect about the x-axis, what we have to do is take f of x and see if it's equal to, when we're reflecting around the x-axis, f of x is going to give us the same y value as negative f of x. Did I say that right? I don't think I said that right. Same x value, same x value. So if f of x is 2x plus 4, then I'm taking negative f of x equal to negative 2x plus 4, and that'll change it to negative 2x minus 4. And so if you look, these are the graphs of the two lines. So 1, 6 will become 1, negative 6. So the x's remain the same, but the y's get flipped. So 0, 4, here's my 0, 4, that'll need to become 0, negative 4. So 0, negative 4. So if we check that, take a 0, plug it in here, 0 minus 4, there's our negative 4. Take your 0, plug it in here, you get positive 4. These two are reflections about the x-axis. Okay, that's going to end video 1.